Record. There we go. I had some internet snags last night in my Skype session with my 1046s where my internet just died, Eastlink died, so I had to do it off of my cell phone, which actually worked out pretty well. So hopefully Eastlink will stay stable tonight. I'm just going to take off this PowerPoint and put up a whiteboard. And we are Wednesday, May the 24th. This is not what we're doing tonight. So I'm just going to take that off. Delete. Oh, there we go. And this is the last session for our Unit 2 quadratic. So I was just saying to Andrew and TJ that the Proctored Test deadline is this Friday. Unless students have requested an extension, many students are deciding to take the extra weekend and then write either on Monday or Tuesday, depending on the availability of their campus for proctoring. And just so that everybody is reminded, when you have a proctored test, you are allowed a calculator and you are allowed scrap paper and you are allowed a one-page sheet of study notes. So a loose leaf, both sides, you can write whatever you want on there. You can write as small as you want, big as you want. There are some people that use up both sides where they can't see any white space, and others that only put up a few tricky spots. So feel free to bring that to your proctor, and the proctors have that information as well. Nice try, TJ, but no, you're not allowed to use Desmos on the test. Desmos is a great tool. I love it. It's great to check graphing and also to see patterns, but we want you to try and we want you to be able to show us that you can graph a quadratic. Now, graphing quadratics in my math lab is not fun. And I noticed that, I think TJ, you were the one that sent me a question where you were trying to graph the x-intercepts on my math lab and it wouldn't do a decimal. If that happens again, try plotting the y-intercept. That seems to work as well. So instead of trying to place the x-intercepts, if they're between whole numbers, try find out what the y-intercept is, and usually that will give you, if the x-intercepts don't work, then the y-intercept will. Awesome, TJ, you're going to go try that now, because that's what I did, and I found on that specific question, the y-intercept was on a whole number, and it worked out. But let me know if it doesn't, because we can revisit that. So what you can't use during the test is you can't use your textbook, you can't use any other extra notes except for that one study sheet, and you can't use any extra browser. You can't open any extra browsers at the Proctored Test, so you must only have the My Math Lab open. But this is not new news. This is the same thing that if you had taken Math 1046 online, it's the same rules that apply. And if anybody has any questions, just pop me an email or give me a call and I can help you out with that. So, and no Desmos, Andrew, no. No Desmos allowed. So that's it. That's an extra browser that you'd have to have open. So you're not allowed, and you're not allowed to use your smartphone either. So they'll be looking for that, that you're only in My Math Lab, that you're only using the My Math Lab graphing palette, that you're using your study sheet and your scrap paper and a calculator. One thing that I did want to say about the test, and then Andrew, I'm going to start off with your question that you sent me because it's a great intro to the quadratics test that we're doing, and that is looking at the quadratic equation. And I had a note here. Let me just bring it up. There we go. So you can write the quadratic equation either in this form, so a function of x, and you have ax minus h all squared plus k, That's one form of the quadratic equation. And then the other form of the quadratic equation is a to the x squared plus bx plus c. And both of these will graph a parabola. One thing that you might not remember or might forget is the names of these forms, because they're very similar. So the first one here, this function of x is equal to a x minus h in parentheses all squared plus k, that's called the standard form of the quadratic equation, and that leaves this ax squared plus bx plus c as the general form. So you can describe a graph either as an equation in the standard form or as an equation in the general form. So you should be able to apply those terms to these two equations. Why you would use one over the other is just the type of information that you get from each equation. So when you graph a parabola, you want to know the vertex, and the vertex is either going to be the bottommost point of the parabola if it is opening upwards, so the minimum, or the vertex is going to be the topmost point of the parabola if it's open downwards, and that's going to be the maximum. So when you draw quadratic equations as graphs and you get your parabola, the vertex is what you want to draw first, and then it's great if you can then find the x-intercepts, and the x-intercepts are always going to be the zeros of the quadratic equation. And we talked about different ways to find zeros in 3.1, I believe, and also in in section 1.4 and in section 1.5. It's all about factoring quadratics, completing the square to solve for x's. So finding the vertex, finding the x-intercepts, and in some cases finding the y-intercept will help you to draw the graph. So that's what TJ and I were talking about, is that when you need to draw a graph using the grapher palette in my math lab, you're going to place your vertex first, so you need to find the vertex, and then you're either going to place the x-intercepts or you're going to place the y-intercept, whichever is easiest, whichever way the grapher tool allows you. How do you find the vertex? Well, if you're using the general form, which is this one here, the x value of your vertex is going to be equal to negative b over 2a. So you're going to take your b value and put a negative sign in front of it, and then you're going to multiply your a value by 2, and that's going to give you the x-coordinate of your vertex. Once you get the x-coordinate, you can then input it in for x and then solve for y. Another piece of information that you can get from the general form is that if you want to find the y-intercept is always going to be the c value. So once you get the y-coordinate for the intercept, then it's just going to be at the ordered pair 0 and whatever c is. So the general form gives you the vertex by using this formula for x, and it also gives you the y-intercept. The standard form, it gives you the x-intercept right away, and that's really the power of the standard form. And the vertex, it not only gives you the x value of the vertex, but it also gives you the y value. And the x value of the vertex is going to be h and k. And that's going to be your ordered pair. So h is going to be your x value, and k is going to be the y value of your vertex. But there's a catch, and that is that And this comes up to your question, Andrew, and I'm going to bring it up. Let me just find that piece of paper that I wrote it on. Oh, there it is. So you, Andrew, had a question about 3.1.9 in the homework, and they gave you the quadratic equation of 3x minus 9 squared plus 3. And they wanted to know, based on this equation, what is the vertex? And I said that the vertex is going to be your h value, and it's also going to be your k value. But it's not with this negative. So your standard form is always going to have a negative in the equation. No, I shouldn't say that. It doesn't always have a negative, because sometimes it's a positive. But if it's a negative in the equation, it means that your x value is going to become positive, and your vertex for this is going to be positive 9 and positive 3. If the equation was written like this, 3x plus 9 squared plus 3, then the vertex would be negative 9 plus 3. So what you have to remember, which is sort of one of these important points in the quadratic unit, is that when you're finding the vertex using the standard form, your x value is going to be the opposite sign of however it's written in standard form. So if it's negative 9 here, then it's going to give you a positive 9 for x, and if it is going to be a positive value written in standard form, then your answer is going to take the form of a negative number. Andrew, does that help? Oh, Andrew's writing me a message.
Yeah, I'll just use the microphone.
Yes, sure.
It was bothering me, that whole thing, so I was mulling it over, and I sort of came up with what you just described, at least in a strange way that made sense for me anyway.
Good. So yeah, that's the big thing, and however you come to terms with that, but yes, if it's a negative value inside the parentheses, then your x value will be positive, and if it's a positive sign inside the parentheses, then your x value is going to be negative. Now your k value is going to be however it's written in the standard form. So if it was negative 3, then your y would also be negative 3 as well. So save the sign for your k value, but the h value is going to be opposite whatever it's in parentheses. And then TJ is asking if should he save his work for extra points. Yes. So what TJ is alluding to is that, and I recommend this for everyone, and I'm trying to really hit this home to my Math 1046 students right now. When you write a test and you submit and you get your mark back, you can always go in through the gradebook in My Math Lab and review your test. And I recommend that everybody reviews their tests and writes down and looks at their test and sees where where the test marked them wrong, and just have a look and see where you went wrong. Is it that you weren't wrong? It's just that you wrote the answer down in a way that the computer didn't accept it. So for instance, I had a student that wrote the answer as x is equal to, it was supposed to be x is equal to 2, but instead they wrote n is equal to 2, so they just put in their own variable, but they had the right answer. To me, that is full marks. So you want to send me any questions where the computer is too finicky and you have the right answer. But you also can send me questions where you have partial answers. So in other words, let's say that you were writing down the solution set for zeros and you got 3 out of the 4 answers, or perhaps one of your answers you didn't reduce down to its simplest form, but it's still correct, it's just not reduced down to simplest form, let me know, and I love to go back and give extra points and extra partial points where needed. So please, if everybody could review their test and then send me an email afterwards with what questions you'd like me to review. I think that's good practice for everybody to go over a test and see where they went right and also where they might have had some weak spots. And you can do that with the pretest too. If you want me to go into the pretest, if you find that a pretest has been finicky as well, that's helpful too. Okay, so that was Andrew's question about why the vertex, the x value seems to change sign, and that was a really good reminder for everyone that when you have the standard form and you're looking for the vertex, it's the easiest way to find the vertex is if you have it in standard form instead of having to use this formula for general form. Just remember that your h value is going to be opposite sign of whatever's happening inside the parentheses. Okay, so with that, I'm going to take your questions. TJ, you had some questions, and I answered some for you already, but did you have any more that you wanted to bring up this evening? TJ might be off working on a pretest. Oh, nope, he's writing. Get my notes together here. There we go. I have the notes from the ones that I did already. I have that 4x to the power 412 that I'll go over. Yeah, for sure, TJ. Do you have that ready now? If I have the whiteboard up, so would you like to paste it, or tell me which one? I might have it here. Okay, perfect, TJ. Thank you. Yeah, whichever is easiest for you. And Andrew, did you have more questions for me tonight as well as TJ's going there, just looking ahead? Did you have any other ones that you wanted to bring to ask tonight as well?
I was just shuffling through to find my cheat sheet. I had a couple questions marked down.
Oh, perfect.
On it, but I was just shuffling through to see, and then I'll refer to my math lab if you want. How do you do that again? Is Control C, Control V, and I can put the question right on the screen?
That should work. Yeah.
Okay, I'll try that.
Okay. Okay, awesome, TJ. Andrew, were you trying to do the Control Copy, Control Paste now? Oh.
No, I wasn't. I was just
okay.
looking. I was just looking for one that I could do it with.
Oh, perfect. Okay, so what TJ's ready, so I'll get him to put his up, and then while you're looking for yours, we'll do that one, and then we'll go back, which is perfect.
Yeah, perfect. Great,
okay,
thanks.
No problem. Okay, TJ, go for it. Oh, there it is. Oh, thank you for a domain range question. So this is great because there are going to be domain range questions on the test. I believe there's probably 3 of them, but once you see the pattern of them, you'll be able to do it. Oh, can we leave this up though? Perfect, thanks TJ. Let's just leave this up for a second. What I wanted to say about domain and range is that either you're going to have a parabola that is negative and opens downward, or you're going to have a parabola that is positive and opens upwards. So let me just put in, just arbitrarily put in an axis like that. So domain is going to be your x values, and you can represent that in interval notation, or you can represent that in set notation. On the test, they're going to ask for interval notation, and interval notation is where you're just going to use parentheses and not use inequalities to describe like x is a member of. You don't need to do that. So in interval notation, the domain is going to be all of the x values that are represented by the parabola. And looking at parabolas, we're looking at all the x values that are included. So we're just concentrating on x because that's going to be your domain. And what you need to know about parabolas is that they just keep on getting wider and wider and wider. So the x values that are included in a parabola are really any real number because they keep opening up wider and wider and wider until they hit infinity. Negative and positive infinity, and that's true for whether you are a parabola that opens up or you're a parabola that opens down. So when you talk about the domain and you have to write it in interval notation, it's going to be any real number from negative infinity to positive infinity. And whenever we do interval notation and we write down an infinity symbol, we always use round brackets. So the domain, if it's going to be a parabola, will always be that, negative infinity to positive infinity. So that's a really, that's going to be a really easy answer because all parabolas have this domain. It's the range of a parabola that's going to be different. And the range of a parabola is going to be all the y values that are included in the graph of the parabola. Now, as you can see on this first parabola, if I were to shade all of the y values, they would start at the maximum. And they would include all the values from that maximum mark, which let's say here is -3, and it would include them to negative infinity because this parabola is opening downwards and it's just going to keep going all the way to negative infinity. So the range is going to be all the y values from -3 to negative infinity. Yeah, TJ, you've got it right. I put -3, you put -7. So for this one, our range is going to be -3 to negative infinity round bracket. The big thing here is that -3 is included because it's part of that vertex, so you have to make sure that you have a square parentheses on that -3. Now, on this parabola that opens upwards, whoops, it's going to be all of our y values starting at that minimum value and then going up and up and up to positive infinity. So the range for this one, let's say that this is -7 here, our range is going to be -7 to positive infinity. Oh, and I just caught myself here. Let me just finish this range. So negative infinity to positive infinity. I've made a mistake with this one. TJ, Andrew, can you see why that wouldn't be correct range? I was too quick when I wrote that down. Can you see how I wrote it down wrong? And TJ, in your -7, negative infinity, you would have had that one incorrect as well. any guesses on how the numbers are correct? -3 and -infinity are correct, but there's something wrong in how I've written down that interval notation. And you know what? The parentheses, the square bracket, and the round bracket are okay as well. So it's not that, but that was a good guess. All I've done is I've put them in the wrong order. You always want to put your smallest number first, and then the biggest number, smallest number on the left, biggest number on the right. And so I should have had -infinity to -3. -3 is bigger than -infinity, so I should have had it written that way. On the graph, yes, I'm reading from -3 down to -infinity, but in interval notation, you always want to write it with your smallest number first, your most negative number first. So that's that would be the proper way to write that that range, -infinity to -3, and then for this range over here, -7 is the smallest number, and +infinity would be the largest. So I'm just going to see if I have, yeah, I have that right. So that's finding the domain and range of parabolas. Your domain's always going to be -infinity to +infinity with any quadratic, but it's going to be your range that you're looking at, and depending on where that vertex is, whether you're dealing with a maximum or minimum, you're going to have to think about a little bit more about what that range will be. I like to color it in. That helps me to see my range, but it's up to you and how you figure that out as well. Okay. TJ, is that enough for that question there? And I'll get, if so, I will delete this and give you a new whiteboard. And Andrew, did I make that mistake did I write it incorrectly in the review video? I should annotate that through YouTube if I did.
I think that you did, because I watched the video again today.
Yeah.
And I didn't catch it the first time, obviously, but when the second time when you're watching something, you always pick up.
Oh, yeah.
So
And
I think you did, because right at the end you talked a little bit in the video about domain and range, I believe.
Okay. I'll have to look back and see and hope that I didn't flip them like I did here. So I'll check on that. And if I did, the great thing about YouTube is you can write over videos now, which is nice. Okay, TJ
I could be wrong, but I think for some reason.
Yeah, nope, thanks. That's great. I will check that out. I'm going to delete this, and TJ, you have another one for me. Now, if that happened on a test and you flipped the domain and range, but you had, sorry, if you flipped the range and you didn't have it in ascending order, you could let me know, and I'd give you like 0.75 for that. I would definitely give partial marks. I wouldn't just give a 0, because I could see that you were on the right track. You just wrote the interval notation down incorrectly. So keep that in mind if you end up having a little bit of a brain burp during the test. So we have the next one. Thanks, TJ. This looks great. Write an equation in standard form of the parabola that has the same shape as the graph, fx squared, but with 2 and 4 as the vertex. Great. So first of all, it's important to know what standard form is, and standard form is going to be this one, f of x, which is a x minus h all squared plus k. So that's our standard form of a parabola. And we're saying that we want it to have the same shape as this graph of f of x equals 5x squared. So if it's going to have the same shape, we need to keep this coefficient of 5. And that's going to become our a value in this ax minus h squared plus k. So f of x is equal to 5. And then they give us the vertex as 2 and 4. So our h value is going to be 2, and our k value is going to be that 4. Now, because h is positive 2, then we're going to make sure that it's negative 2 inside the parentheses, because remember, that's what we had talked about at the beginning of the video. And then our k value is positive 4. So it's going to, this is the standard form of a parabola that has the same shape as 5x squared, but whereas the vertex for 5x squared would be at the origin, 0 and 0, this one, the new one, has a vertex that's moved over by 2. Now, if that was a negative video, would you do the double negative of negative 2? You mean if the vertex was a negative 2 and 4, then yes, you'd have negative 2, because your h value is negative 2. So this is another way to look at it. It would be a negative 2, and whenever you have a double negative, that's equal to a positive. So you would have that would be the graph if our vertex was negative. Yay! Sound good, TJ? Awesome. Very good. Andrew, how does that sound to you? Because I think there's probably going to be a question like this on the test. I think I did something like this today.
Oh, I think I could manage it as long as I write standard form and general form and differentiate them on my cheat sheets.
Yep.
I think I can get it.
Yeah, put that at the top.
Yeah, no doubt.
Yeah. TJ, any more for me for that one? I'm chomping at the bit to do this difference of cubes. But I don't need to do that. I can leave that to the end. And you know, when you're finding zeros, when in doubt, use the quadratic formula, because it's the one that will give you your x's, no matter how hard it is to factor something. But on the test, it is going to give you, it's going to say, here's the equation, factor it this way, and how they ask you to factor it is going to be the easiest way to factor. But remember, you can always check any of your factoring using the quadratic form. And TJ says he can find something else, but he has nothing at the moment. Andrew, are you good to go, or would you like me to do the factoring of the difference of cubes? I know I was going to show you an example of that in just the process, because both of you asked me the same question. Do you want me to do that now and just get that off of our plate?
Sure, that works for me.
Okay. And TJ? Perfect. Awesome. So the example that I wanted to show you tonight is this one. 4x4 is equal to 32x. And they want us to factor out the greatest common factor and then use either the difference of two cubes or the sum of two cubes to help us to factor. And I think it was you, Andrew, that said, I think I remember something about this in 1046, but I've forgotten about it. So I'm just going to show you the process for it. The good news is that this type of factoring isn't going to be on the test, but I'll show you what is, and I'll talk about that after this. But basically, the first thing that you want to do with this is you want to get the 32 over to the other side and make this equation equal to 0. So 4x to the power of 4 minus 32x. And I should have preface this as we're trying to find the zeros of this equation, because that would be the x-intercepts for the graph if we were to draw this. Once you get this far, you're going to pull out the greatest common factor, and the greatest common factor for both this term and this term is going to be 4x. It's common to both. So I'm going to pull that out of the expression, and what I'm left with inside is x to the power of 3, and the reason for that is that 4x times x to the power of 3 is 4x to the power of 4. And then my other term, negative 32x, if I divide that by 4x, I'm going to be left with 8. And the reason for that is if I multiplied 4x by negative 8, I would get the term negative 32x. So I've pulled out my greatest common factor, and then I get this new expression. And right away I can see that I can then using the zero principle, set 4x equal to 0, and I can also set x to the power of 3 minus 8 equal to 0 as well, and then I can solve for x. Now it's really easy to solve for 4x equals 0 because I can just divide both sides by 4, and I get x is equal to 0. Whoops. So that's going to be one part of my solution, is going to be x is equal to 0. Now this is when I need to use the differences of cubes, because I need to factor this, x to the power of 3 minus 8. I want to factor that, and I want to use this rule that whenever you have the difference of cubes, and this is a difference of cube because x to the power of 3 is a cube, but 8 is also a cube as well, because 8 is also 2 to the power of 3. So this is a difference of cubes, x to the power of 3 and 2 to the power of 3. And it's the difference of cubes. And we know from 1046 that when you're factoring difference of cubes, you are going to get this pattern: a to the power of 3, b to the power of 3. So this is just the pattern that they give. You're going to get a minus b as one of your factors, and a2, plus ab plus b to the power of 2 as your other expression. So using this formula, I can then factor out x to the power of 3 minus 8. What I like to do is rewrite it, the 8 as 2 to the power of 3, just so that I can see it's in that difference of cube form. And a is going to be equal to x in this case, and b is going to be equal to 2. Now what I can do is I can fill in my variables here based on that. So this first part, a minus b, is going to be x minus 2. And then the second part, I'm going to have a to the power of 2, so x squared plus a times b, which is 2 times x, and then b squared is going to be 2 squared, which is the same as 4. So I'm just going to put 4 in. How are you guys following me okay to that point, in that I'm using just this pattern of the differences of cubes, sorry? I think the question with this one is that you'd have to have that pattern remembered from Math 1046, which is a really, really big ask to remember that. Awesome. So then once you get it to here, you can then set x minus 2 to equal 0. And then solve for x, so that's going to be 2. And then x squared plus 2x plus 4, I'm also going to have that equal to 0, and then I have to I have to solve the x's for this. And this is where it gets a little bit tricky. So far, I have part of my solution set. I know that x is going to be equal to 0 as one of my x-intercepts. It's going to also be 2, but this you can't factor out easily. So you have to use the quadratic formula for this one. So x is equal to negative b plus or minus b squared minus 4ac over 2a. And the reason why I'm using the quadratic formula is that this is not easily factorable. I can't find two numbers that when multiplied together give me 4 and when added together give me positive 2. The signs just don't match up. So what I'm going to do is I'm going to enter in, and even though this type of question isn't going to be on the test, it's only in your homework, being able to simplify a quadratic formula is. So you will have to use the quadratic formula on the test, and you might get a quadratic formula that looks like this. So what I've done is I've inputted my a value, my b value, and my c value into this quadratic equation, and I'm left with negative 2 plus or minus the square root of 2 to the power of 2 minus 4 times 1 times 4 all over 2 times 1. And this is what I get. Negative 2 plus or minus 2 times 2 is 2 to the power of 2 is going to be 4. And negative 4 times 1 times positive 4 is going to give me negative 16 underneath the square root, and that's all over 2. And then I'm going to simplify this again, and under my bracket 4 subtract 16 is going to give me negative 12 all over 2. Underneath the square root has a special name. Andrew, TJ, do you remember the name of the number underneath the square root? Give you a hint, this number is going to tell you how many solutions you have. If you have like 1x, 2x, or imaginary x-intercepts. The radicand is going to be what the any number underneath a square root or a radical sign is a radicand. But this is called the discriminant. And TJ, you are right. The discriminant is going to tell you if it's negative that you have imaginary roots. So that means that the parabola is going to be floating either above or below the x-intercepts and not actually cross it. Yes, Andrew, I was thinking of the very specific name for just underneath the radical sign in the quadratic formula. So this negative 12 is telling us that we are going to have imaginary x-intercepts. And you should be able to, on your test, simplify something that looks like this. And this is how you do it. Negative 2 plus or minus. What I'm going to do with this negative 12 is I'm going to parse it out. I'm going to do its multiples. So I'm going to first take out the negative 1, and then I'm going to multiply 3 times 4. That gives me negative 12. And the reason why I parsed it out that way is that I want to be able to simplify this, and it's going to give me negative 1, the square root of negative 1, times the square root of negative 3, times the square root sorry, these are positive, square root of positive 3 and the square root of positive 4. And then I can simplify. The square root of negative 1, what is that? How can I simplify that? Right, that's going to be your I value. Awesome. and the reason why is that there are no two numbers when multiplied together that give you a negative number. And then the square root of 3 we can't do anything with. That's as simplified as we get. So I'm going to leave that. But the square root of 4 is going to be 2. So I'm going to put that 2 in front of the I. That simplifies that. So that's 2. That stays the same, and this becomes I. And so I rewrite it so that I have the 2 in front of the I, and that's all over 2. So our solution set is going to be the solution to this quadratic equation that we add to already our solutions of 0 and 2. But because the denominator is 2, I can reduce this even further. 2 divided by 2 is negative 2 divided by 2 is going to be negative 1, and 2 over 2 is going to be positive 1. So I can just cancel out the two 2's here, just leaving me with I square root of 3. So this is the final reduced answer of this quadratic. And you will have to simplify a quadratic that has a negative discriminant into the imaginary number, so you're going to include the I value, and you should also be able to reduce the fraction as well in order to get the full points. So if you get to this point, that's great, but for full points they want you to get to this point down here. But you'll get some partial marks, TJ, for having for at least getting it down to almost down to the final part. It's just that when you look at your denominator, see if it can go into any of the numbers in your numerator, and if you can, take each of those numbers separately and cancel them out. Now in my solution, I believe my solution set, let's look, was 0 and 2. So when I write this as my solution set, it's going to be 0, 2, and then I'm going to do negative 1 plus I square root 3 and negative 1 subtract I square root of 3. Because remember, in the quadratic formula, you have this plus minus, so it's going to give you two separate answers. And so for this it's not a quadratic equation, it is a polynomial in the 4th degree. We have 1, 2, 3, 4 x intercepts, or 4 zeros, in which that graph is going to pass through. So that's sort of definitely one of the harder questions that you have gotten on your homework, but you won't have to do that on the test. And Andrew, you're right. This x to the power of 4 graph is going to give you a wavy line, and that's why you have 1, 2, 3, 4 x intercepts here. Okay. I want to put up one more thing for you. And that is something that you will see on the test. And that is find the zeros of a polynomial that does have x to the power of 4, but you don't have to use the differences of cubes. Let me see. Here we go. So same thing, except this time we get something like this. So this is a bit different because unlike the other one where it was x to the power of 4 plus just an x, you can see that this actually, if you were to rewrite it, 30x to the power of 4, I'm going to bring everything over to the left side, 85x to the square plus 49 equals 0. if you look at this, even though it's not a quadratic because the highest degree is a 4, not a 2, it's in quadratic form. This is the one where you say u is equal to x squared, and then you insert u in for everything that's x squared. So this is going to become negative 85u plus 19. And this 36x to the power of 4 is going to become, if, sorry, u is equal to, yes, u is equal to x squared. So this is going to be 36u squared. There we go. So what I've done is I've taken this equation, I've rewritten it so that we have a polynomial with our exponents in descending order. And then looking at that, I'm like, you know what, that kind of looks like a quadratic. If I take u and make it equal to x squared and then put it in, I will get a quadratic. And what I can do with this quadratic is I can factor it out and find out what u is equal to. Now the factoring out process for this one is a bit hard. And the reason is that if you wanted to use the British method, you would go 36 times 19, and I need my calculator because I can't do that in my head. 36 times 19. So we're looking at two numbers that when multiplied together give you 684, but when added together give you negative 85. These are huge coefficients. So I'm not going to do it that way. I'm going to use the quadratic formula. And when I use the quadratic formula, u is equal to negative b, which is going to be negative 85, plus or minus negative 85 squared minus 4, that's a 4, times a. A is going to be 36, and b is going to be 49, like that. All over 2 times a, which is 36. Eventually what you get when you do all the calculations for this, you're going to get this. U is equal to 85, because negative 85 is positive 85, plus or minus the square root of 169. So the discriminant is positive 169. All over 2 times 36 is 72. And the square root of 169 is 13. So u is equal to 85 plus or minus 13 over 72. So I've skipped some steps here. Where do I get the 169, TJ? Negative 85 squared is going to be 7,225, and then negative 4 times 36 times 49 is negative 7,056. So this in here is simplified. This is the step that I missed. 7,225 minus 7,056 is going to be equal to 169. Okay, and then I get the square root of 169 is equal to 13, and then that's going to give me, so 85 plus 13 is 98 over 72. And 85 minus 13 is 72 over 72. So there are my two values. I can reduce this fraction of 98 over 72. I can divide each by 2, and I get 49 over 36. And for this one, I get u is equal to 1. So I've just solved what u is, and the big problem is a lot of people go, there, I found the zeros, u is equal to 49 over 36, and u is equal to 1. But you have to remember that at the very beginning we said, no, u is equal to x squared. So we have to go back down here and exchange u for x squared. So u becomes x squared, which is equal to 1. And now we can solve for x, and that will be the true zeros for this quadratic equation. And to do this, I'm just going to find the square root of both sides. So the square root and the x cancel out, and I'm going to get plus or minus the square root of 49 over the square root of 36. And the square root of 49 is going to be 7, and the square root of 36 is going to be 6. So x is going to be plus 7 over 6, x is going to be negative 7 over 6, and then up here I'm going to do the same thing. X is equal to plus or minus the square root of 1, which is going to be positive and negative 1. So the solution set to this one is going to be plus 7 over 6 minus 7 over 6 plus 1 and negative 1. So 4 intercepts for this polynomial. It's not a quadratic, but a polynomial in the fourth degree. So you will have to apply this skill to a question on the test. So if you can find some extra questions in your textbook that involve this, I'm sure that they did some in the first 2 sections for this unit. You can go back and look at it. I remember doing this in a video, but this one's a good one that you'd want to make sure that you go over. Oh, I'm sorry, TJ, I cut out for 20 seconds. I think that it will pick it up in the recording, but if you're all good with that, are you okay with how I got these solutions here? I'm trying to think of how far back 20 seconds would go. Maybe this part here, that x is equal to plus 1 and also negative 1. Perfect. Andrew, what about you? TJ's saying he's going to make sure that he has an example like this on his cheat sheet.
Oh yeah, I will too. I mean, I'm gonna heavily. I mean, it seems kind of unfair almost, but I'm gonna heavily lean on the pretests to see where my cheat sheet takes me.
No, that's not unfair at all. That's great strategy. And as you're doing your homework, like my feeling is that as people are doing their homework, they're highlighting questions that they are having problems with and creating study notes from that. And then as you go to your pretest, you start to polish what you need to know for the test. And then after you do your pretest, that's when you get your cheat sheet together, and your cheat sheet are going to be those reminders of places that you are a little bit weak on, and then you can use that for your test. The more specific you can be on your cheat sheet, the better, and that takes a lot of hard work. So there's no way that that's taking the easy route at all. To create a great cheat sheet takes a lot of hard work and a lot of practice. So if it turns out that your cheat sheet, allows you to get a really great mark on your test, it's because you've done the hard work beforehand. So that's fantastic. TJ, there's a lot of people that are putting their cheat sheet together the night before. But I'm sure you're doing it from the homework and from your questions that you've been asking all along. So I think you're too hard on yourself. So other questions that you might have? That was mine that I brought in. You guys didn't have a question on that, but I just wanted to show you that. And I'm going to look at my notes that I did and see if there's anything else that I wanted to draw your attention to. So just looking at the test, for sure you want to know how to factor different types of equations, and as they say, they're really going to tell you how they want you to do that. And if you need to check your answer, use the quadratic formula. You should be able to apply the quadratic formula anytime. And if you do get an imaginary number in the quadratic formula, as I showed you in a couple of slides ago, you should be able to simplify the answer so that you're in the most reduced form. Don't forget to look at discriminants and how you know whether you have one solution, two unequal solutions, or an imaginary solution. You should be able to apply, there's a couple of questions where they're going to give you a formula that's going to describe, let's say, a projectile or a real life situation that takes the form of a parabola on a graph. And they'll give you the quadratic formula and they'll say, for instance, let's say you're throwing a ball from 5 feet in the air. What's the highest it's going to reach if we know that the equation is this? So you should be able to put in x values to to figure out the output, what the y value is going to be. So there's a couple of questions that involve application type questions. So in terms of throwing a ball, that sort of a thing. So if you can have a bit of practice with those, that would be great as well. Excuse me, I just have to cough, so I'm going to turn off my mic for a moment. Sorry about that. TJ, so like the last question on the pretest, I'd have to look at that pretest. Do you have it there that you could just copy and paste it onto the board? TJ, that might be the easiest. No problem. Andrew, while TJ is going off to find that, do you have any other questions?
No, I think that the one that you brought up was the one that I was going to get at, because I did exactly what you described. And I did it twice.
Oh, okay.
That I used, that I thought I found my x's, but I forgot to go back and sub in x squared for you.
Yes, yeah. I think that we get so excited that we've got the answer and it looks like something that that we forget that we have to go back. So just remember that. And TJ, this is exactly what I'm talking about. So let me just grab my pointer. So this is kind of like a real world example of an application problem with a parabola. So an athlete whose event is the shot put, so you know where you throw that big round lead ball, when the shot whose path is shown by the graph, so the graph is very parabola in shape, and it opens downwards, so we're going to have a maximum, is released at an angle of 35 degrees. Its height, which is fx in feet, can be modeled by f of x is equal to negative 0.1, 0. So this right here is going to be the equation of the parabola that gives this pattern for the shot put, where x is the shot's horizontal distance in feet from its point of release. So what I like to do when I get a question of like this is I want to know what x is and I want to know what y is, so what my f of x is equal to. And my x is, they say, is going to be my horizontal distance from the release point. My pen's not working that great as usual. And y, they say right here, is the height. So knowing that x is going to be the horizontal distance from like how far it is from the release point, and y is going to be my height, then I can, if they give me one of those variables as data, I can solve for the other by putting them into the equation. Now, first of all, they don't get us to do that. So they say, what is the maximum height of the shot and how far from its point of release does that occur? Well, the maximum height is going to be the vertex. So it's going to be our x value and our y value. And of course, this is in general form, so we have to use the formula of negative b over 2a to solve for x, and that's going to give us the distance from the release point, and then we'll put that answer in for in for x, and then we'll solve for y, and that's going to be our maximum height. So when you think about the vertex, you have to think that the maximum and the minimum are your vertex, and then you have to think of what does x stand for and what does y stand for. So and we already wrote down what they stand for here. So that's going to be how you find what your maximum height is, and which occurs at what point of your release. So this is going to be my y value, and this is going to be the x value of my vertex, which I find by using this formula to find x, and then I'm going to input it back into equation to solve for y. Are you both okay with that for the A part?
Yeah.
Okay, cool. And then, cool. And then B, what is the shot's maximum horizontal distance to the nearest tenth of a foot or the distance of the throw? So the maximum horizontal distance is going to be the point at which it hits the ground, because then it's going to stop. So when you look at this point, you can see that it's going to be one of the x-intercepts. And that x-intercept is going to have an x value, and it's going to have a y value. So what you're going to want to do is you're going to want to put these numbers into the quadratic formula. You could factor, but you can see that we're dealing with decimals, and it's really hard to factor when you have decimals. So it's best to use the quadratic formula to find your x-intercepts, and the x-intercept, where the x has the positive value, that's going to be the horizontal distance from the release point. So you can see how the x-intercepts can give you information about the situation, and in this case, that x-intercept, one of the x-intercepts here, is actually when the ball hits the ground. So if you solve for it, you can find out again the horizontal distance from the release point. And lastly, from what height the shot was released. Looking at this graph, it's showing, I've written over it and I can't delete it without deleting the whole thing. But how would you find that exactly? If you looked at it from the graph, I think that it's not exactly on a whole number, so it's going to be a decimal. How could you find out what the exact height is from which the shot put was released? So if you're thinking of a shot put, you've got a person holding the shot put at shoulder height. How would you, what part of this graph are we looking at this release point? It would be the y, yeah, but it has a special name. Y-intercept, exactly. You'd find the y-intercept, and the y-intercept is hiding right here in plain view. In the general form, C value is going to be your y-intercept. So when y is equal to 6.4, then the shot was released at 6.4 feet. So that's your y-intercept. So these types of questions are getting you to find vertexes, x-intercepts, and y-intercepts, but applying them to a real-life situation where those things actually mean something. The vertex is going to be the maximum height. The x-intercept is going to be the distance that the rockets traveled. The y-intercept is going to be maybe the height at which a ball is thrown, or the height at which a rocket takes off, or the height in which a person dives off a diving board. So that's when you're doing these types of questions, just remember that each of those key points of a parabola, the vertex, the zeros or the x-intercepts and the y-intercepts, mean something in the story of the application. And if you can relate those key points to the story, then you've got it made. That's why it's always nice to draw it out too, so you can kind of picture what's going on. So you'll see one of these types of questions on the test. It might not be a shot putter, but it could be a basketball player or a diver or something like that. Yes, I agree, Andrew. Thanks for the question, TJ. So we are past our time, but I think it was well worth it because we went over lots of questions. And TJ is just worn out. TJ, you're writing on Friday, so if you have any questions between now and Friday, you just send me an email, no problem. Or you can also post in the Q&A, whichever you feel most comfortable. And Andrew, you're going to write next week, and the same goes for you. Just let me know if you have any questions. And those of you that are watching, we hope that you have found our questions helpful and our answers. And if you have any questions between now and your test, please let me know. And if you haven't requested an extension and you'd like an extension, let me know. Oh, Andrew and TJ, you guys are off on a tangent now. Do you guys have any more questions before I let you go off to the tavern? I shouldn't say let you, I should wave you off. Adieu. Perfect, TJ. That sounds great. And Andrew's thirsty. Okay, I'm gonna hit the stop record and let that process. And I wish everyone best of luck on this second